Hello everyone, welcome back. So in this video we are going to see the dry run of the network recovery path. Okay, so actually I forget to do the dry run in the previous video that I modified, right? So I thought to create the dry run so you will understand. Okay, so let's continue to see how to do the dry run. Okay, give me 1 second. So we are here. So very first we want the maximize path score, and path is from, let's suppose, 0 to 3, right? Because if you'll see here this example as we have given, right? So we have a node that start from 0 to 3 and this is the valid path, and we have already seen the graph, right? So all intermediate nodes are online, and so the total cost is less than equal to 36, right? K we have given, and so the score is equal to minimum is on the path and we have to return the maximum such score, right? Means if we will take this example, right, this is the edges we have given and this is our online nodes are there, and K we have given is 36. So initial setup how we are going to do on the binary search that we have already seen, right? Means we do binary search with the mean edge cost, and mean edge cost which is allowed in path from we can say low is 0 and high is at 10 to the power 9. Can we see that? So each iteration mid equal to low plus high will do the divide, and we'll check if a valid path exists using the edge having greater than equal to the mid. If yes, we'll move the right, means low will become mid plus 1, and if no, we will do the move left side and we'll do high equal to right minus mid minus 1, right? We know that. So let's understand the very first iteration where low is 0 and high is at 10 to the power 9, we can say that, right? So mid will, let's suppose the mid will become what? We'll do the divide, low plus high by 2, it will come around this, right? So we'll do the filter edges should be greater than, let's suppose, 500 m, right? And so no edges survive in this list, right? So no path is there. We'll say high is, will reduce here. Like that we will keep iterating. Means let's suppose mid will come like this, right? So we'll say no path, will go high like this, we'll do reduce again one more, right? Like this we'll repeat until we reach the actual mid edge value in the graph, right? So let's skip forward to when mid is equal to 4. Can we say that? We can say that, right? And that is why this type of concept you have to understand like that. Okay, so let's suppose now mid we have at somewhere at 4, right? So when iteration 1, we low was here 0 and high was here, low is at 0, like this means we are keep going all the iterations, right? Understood? So let's suppose when we reach there, so let's suppose the mean cost we have is 4 and max cost is 42, but binary search we are doing from 0 to this one, right? 0 to this one. So we'll keep doing that, right? So all the iteration will happen till the iteration, let's suppose, will come n equal, this is n, this is 0, right? So at such iteration, let's call the iteration is n, low is 0 and this is 42, right? Now what we have to do, low we have to update, right? Because we'll get the mid, right? And mid will come what at 21. It means we will check the we'll try more, right? So this is your valid path will get, but we'll try more, so that you will get low will become at mid plus 1, so it will come 22, right? And high will be remain at 42. Again we'll check the what you call the mid, it will become 32. We'll try one more, we'll do plus 1, right? And we'll get 33. Like this we'll keep going that until we'll reach to the 35 here, right? So when low is at 35 and this high is at 34, right? We'll see that mid we don't need that anything, we'll just stop it here, right? Because here we got the final 4. Okay, means we are trying to go for all the what you call low, we are iterating this one, right? And then we are trying to find the final value, right? The result. So each move will get the value, right? So what we have tried to do, first of all we'll find the mid, right? And then we'll check if yes, we'll move right side, means mid plus 1. If not, we'll do minus 1. And that is why we are checking each of these, right? So we started the first iteration like this, then second iteration this. We'll keep repeating until we reach the mid value in the graph, actual mid value we can say. And then we'll skip forward when mid equal to 4, right? So somewhere we'll get here 4, and then we'll say okay, fine, just stop it here. Okay, no further required here, and we will return the value here. Okay, now understand how the actual value works on here. So let's suppose the iteration is here, right? And all these iterations are there. This is your low, this is your high, right? So when you got this, right, we are including all of these edges at when it is valid, right? We are including 2 and 3, 1, 2, like that. We are iterating and we are getting the edges, all the edges, right? When we are done, we'll stop it here, right? Then we'll find the from 2 to 3 and 1 to 4, we'll find the what do you call the answer, right? We'll get the valid answer, right? Once you get the valid answer, you will return this is the final answer we have, right? We have seen this example, right? So we have filtered the graph, right? We have keep only the edges that having cost greater than or equal to 4, means we have the only 2 node we have seen, right? As you can see, we have get only these 2, and then we have a stop it, right? So we will get these 2, right, like this, and we can say that topological sort by DFS will filter. Like these are the 2 things we have. We'll do the DFS, we'll do the visit like this. First we'll go from 0, then 2, and then 3. Then we'll push all of these because we are using the topological sort, right? And for here we'll do the DFS from 1, and we'll do visit 1 to 2. We have already visited it, so we'll push it, right? And the topological sort is become 1, 0, 2, 3. Can we say that? Now we have to iterate over the topological sort, right? So what we need to do, very first we have initialize 0, then just at 1, 3. You can keep looking at your code also. Okay, so you have the deep initial, we have initialized very first, we initialize, then we have to assign infinity value for from 1 to 3, we can say that. Then for each node, what we will do, for each is 1, let's suppose we'll say 2, right? Cost is 42, then we have distance at 1, right? It is infinity, we'll skip it. Like that we'll get node 1, node 2, like that we'll keep going, that we will get the value here, right? Like this will go. Okay, then we'll say node 2 we are getting 26, node 0 we are getting 4, and node 1 we are skipping 1. Okay, so no outgoing edges have from the node 3, so we'll stop it here, and we'll say we'll check the value here. 26 is less than 36, so this is valid one. So what we will do, we'll say valid path is 0. As we can see here, we got here 4, right? And then we have another is this one. So we will add this. We'll say 26, and this 26 is less than 36. We'll say this is valid one. So mean age is nothing but 4. In this 4 and 22, which one is the minimum one? So 4 is the minimum one. So we'll update our minimum score. Okay. So if you do the dry run of this example, right? So very first what we have filtered this, right? After the filter this, we have removed, right, this path, and we can't reach from 2 to from 0. So no path to the 3, no valid one, let's suppose. So we'll say by final binary state will become valid max is 4 and low is at 5. Can we say that? And high is at 3, and we will stop it here, and that is why we are returning answer 4. So if you represent the DAG, right, how can you represent this example, right? So from 0 we are going to 2 and then 3, means we have 4 and 22. So the minimum is we are getting 4 here, right? But there is another we have is 1. If we'll take from here is 42 we have given, right? Means the valid age is itself we have, means 4 and 22 is the valid one, right? And we'll say minimum is 4, and so we are getting this one, right? So and then we have already seen what is the core objective, how we have solved this, right? We have already seen that. So that's all for today, and thank you guys. If you like this video, let me know in the comment section that you understood here. Thank you for watching this video. I'll see you in the next one.